This is a RTM 3000 series. In Rodent stores, RTM 3000 is a, from basic, it is the third level of the oscilloscope, and this is a display part. This is a vertical, this is a horizontal, this is a trigger, this is the action, and this is the analysis. So this is a, on the display we have the five types of operation sections in the on the front panel. Even these same buttons we can even operate from this side. We have the vertical, logic, trigger, horizontal. All these menus are available in the even on the soft panel. Okay. So now I am connecting. Yeah. Now I have connected. Here in default in every oscilloscope we will have the 1 kilohertz probe, 1 kilohertz oscillator to check the probes. So now I have connected that. So with this, so we are seeing this waveforms on this. Like if you see on we have, there is only one control for vertical section, but there are 4 channels. Controller is only one. It depends on the color dependent. If you see the yellow, this is the channel 1. This is like yellow. Channel 2 green. Now it is a green. Channel 3 orange. Channel 4 violet. So based on the colors, which color is showing in the control, so that channel is active. So if you see now channel 4 is moving. Again if you see now it is orange, channel 3 is moving. If you see channel 2 green is moving. If you see channel 1, depending upon the color, so we can control the oscilloscope with one controller. Okay. And now this one is the vertical. Now I will go to the in-depth of the menus. Like this is a vertical. Okay. Now this is a vertical. Now this is a channel 1. So here you can see state on, off, and AC DC. And whenever you connect our same R&S oscilloscope probes, so if you see now both 50 ohm and 1 meg ohm is active. If I connect now, see now it got disabled. The reason behind this, these normally this front panel, these connectors will have the 2 types of selection, 1 meg ohm and 50 ohm. And when you connect our R&S probe, here there is a pointer. Whenever this pointer go and touches this connector, so it will detect, and by default it will select, it will do the selection. So no need of we selecting this thing. And even you can limit the bandwidth. Now you can see full 500 megahertz is there. We can limit to 20 megahertz also. 20 megahertz, 100, 200, 350, 500. Even in this RTM series, even we do have the 1 gigahertz also. Like so, this is the thing. This is a vertical scale. Like here, this also is a vertical scale. If you see here, this goes from 5 millivolts. Goes up to 100 volts. Actually, if you see this, even we can do the fine tuning also. Like we can do the fining, 5.3 volts, this thing. So it is, we can do in this. Okay. So this is how we can, this is a vertical scale. And coming to the probes here, so this is the, by default it is 10:1 probe. So when we connect this, it will select. When you using the high voltage probes, so here you can use 100:1, 1000:1. Okay. And like even every passive probe has its own frequency. So normally for passive probes will be only up to 500 megahertz, not more than that. Okay. So this is the specifications of the 500 megahertz also probe. Here you can see this is the 500 megahertz is the this thing in 10:1. When you make 1:1, so this by default this probe bandwidth will become a 32 megahertz. Okay. So but when you are measuring any low level signals, then you can go for a 1:1, or else you can keep in a normally 10:1. And when you use high voltage probes, So there you can go for 100:1 or 1000:1 according to your application. You can select them. Okay, and then coming to this units, in this we can measure the voltage with passive probes. This along with this, here we can give the input of up to less than or equal to 300 volts RMS or 400 volts peak to peak. If you want to measure the current, that is also possible. In the units you go to the amperes. Okay, and for to measuring the current you need a current probe. So where you can select the 1 volt per amp, 100 volt per amp according to the your current probe, which on that it will also mention the alternations also. So this is like this. Okay, and coming to the trigger, so this is the trigger position, this is the auto mode. Auto means automatically it will set the trigger. If you press normal, manually we have to select the trigger. And here we have various trigger types. Normally we use edge trigger. In the vertical, just I want to forgot tell you one thing. Once after you feeding the this thing, you can see the block diagram here. So how your signal is getting processed internal. So a fresh engineer also, he can easily understand how your signal is getting processed internally of the oscilloscope. So not only in vertical, in every stage you can see, if you select the trigger, this is edge trigger, and your slope is rise time. So you can see where your trigger is, at which point your signal is getting triggered. So this is how this is how the trigger level works. Okay, and coming to the horizontal also, it is mentioned, it is showing that it is in the middle part. If you want to change, you can change it to the left. Now it went to here. If you want right, it came at this point. But to see clear view, we keep in the middle. And just I want to confirm one more thing. Here if you see, here it is mentioned at the 5 giga samples, also 5 giga samples. In this on all channels it is 5 giga sample sampling rate. If you use on all channels it is 2.5 giga sample sampling rate. If you use only 1 and 3 channel, the sampling rate will be 5 giga samples. If you use 1 and 2, by default it will fall down to 2.5 giga samples. Like we have the interleaving between 1 and 3 and 2 and 4. So that is how you see. Now again I have switched off the second channel to, it has become 5 giga samples. Here even just I want to show the acquisition memory also. This RTM we have the maximum memory of 80 million points. If the channel 1 and 3 is there, it can be up, you can do the memory of up to 80 million points. If I switch on the channel 2, the memory is only up to 40 million points. Actually as per our data sheet, memory is 40 million points memory on each channel. And even if you normally we select automatic, depends upon the frequency and the sampling rate, the memory by default equipment will be calculated. If you want more memory, you can select the high memory. And here we have the various acquisitions, even that I can show you on from the desktop. Here sample is there. I'm doing peak detect. So still you can see, still noise has increased. I am doing high resolution. You can see the thin line total noise got suppressed. If you look at average, it is taking 2 averages. If you want to give more, the more average is also possible. So minimum is 2, maximum is 100k. So right now I am giving 10 averages. So it is doing 10 averages and it is displaying. Even if you see at acquisition average, you can see what is the single, what is the multiple average. In the same way, even if I do the high resolution, so apart from normal ADC, this is doing the high resolution. So this is the peak detect. It is adding the peak. So this is how the different types of algorithms we can add on the signal. Okay, after algorithm, acquire is also our measurements. So in measurements, if you see at measurements, we have, so in the basic we have around 7 measurements, and in the vertical we have this many, and in the horizontal we have in also on the count. If you see at anything, you can see from peak to peak, from where to where it is measuring, period from where to where it is measuring. And in the vertical, if you see, if you look at the mean value, RMS value, here they are giving the formula on what basis they are measuring they are doing the measurements. And at a time on the display, here this is totally of 34 measurements are there, but on the display it will display only 8 measurements at a time. You can select any 8 of those. Okay, now one I selected, second one on, I am changing to the peak, third one. So this is how you have to, you can switch on the 8 measurements on all 4 channels. If you want to do on one channel, it is possible. If you want to do on all 4 channels, here this is the source. Here you can change the source on which channel you want to do other measurements also. So this is how you can do the measurements. Okay, after measurements we have the cursors. These are cursors. In cursors also you can see from weight T1, weight T2, what is delta T. So like this we can do vertical, horizontal, vertical and horizontal. In vertical you will get 2 cursors, in horizontal you get 2 cursors, in vertical and horizontal you get 4 cursors. Okay, so even as it is a touch screen, you can even operate with your fingertips also. You can see, now this is the third cursor I am placing here, this is the fourth cursor I am placing here. So this is the second cursor I am keeping here. Even you can do from this also. So which channel is active, that will be in a straight line. Other cursors will be in a dot form, those are deactive. Whichever is in the straight line, that is active. So that you can rotate with this knob or with your finger, any way you can operate the cursors. Here we have the values T1, V1, T2, V2, delta T, delta P. So these are the values we can see here. So these are the cursors. And apart from in cursors, we have the other thing like track scaling. So even if you change automatically, if you change the vertical, cursors also will move according to our waveform. Set to trace, so automatically it will, if you select set to trace, automatically it will go and set to the one waveform. So these are some advanced measurements we can do with the cursors. After cursors, this is the math. In math, at a time we can switch on 5 maths. You can select any channels, and these are the operations we can do: additional, subtraction, multiplication, division, square root, absolute value, reciprocal, inverse. So these are the things where you can do math on your waveforms. Okay, so in this oscilloscope, apart from regular oscilloscope, we have some other features which I want to show you. So normally just I have shown you the measurements where you have to manually select the measurements. Out of 34, it will display only 8. Here we have one button called quick mesh. So by pressing this one button, so this around 9 measurements will be displayed at a time. So here you can see volts peak to peak, rise time, mean cycle, P minus, fall time, RMS cycle, time base, frequency, volts peak to peak. So these are around 9 measurements which is easily you can measure at a time by pressing only one click. So this is a one thing. And apart from this, like if you are using all 4 channels, so if you may confuse sometimes which channel connected to which channel. Like example, channel 1 is on clock, channel 2 is on data, channel 3 is on something else. Okay, for identification you can do one thing. So here we have the annotation. So we have the 4 pens, coloring depend upon the color depend upon the channels. Okay, so like this you can mark if you want to highlight anything, and if you want to show it to your superiors, or you want to do the documentation. If you are getting any glitch or anything, a spike or anything, there you can round up like this. You can add text, or else even for your identification also you can you can add text on the signals, like it is a data signal. Data signal, enter. So if you want, you can here. So on the channel 2, it is in green color. It is like clock signal. So like this, even you can keep it for your identification, or if you got any glitches or anything where you want to highlight in your documentation, or if you want to show it to your superior, so there also you can do a roundup or anything, and you can show it to your superiors. And even we have the eraser here, where you can erase these things, and even we can remove the text. Right. So this is the one thing. And normally I have one demo video. What is the difference between 10-bit ADC and 8-bit ADC? The oscilloscope incorporate 10-bit ADC. They support 1204 quantization level to precisely determine the vertical values of each sample. So you can see the difference. The blue one is 8-bit ADC, the yellow one is 10-bit ADC. This is the difference between the ADCs. That's the reason R&S provide all 10-bit ADCs oscilloscopes. Okay. In this oscilloscope, even we do have the 25 megahertz function generator. So where I will use now that. Okay. So here we have the generator port. It is a on. Here we have this many waveforms: DC, sine, rectangle, sync, pulse, all these things. Sine is it is up to 25 megahertz. Pulse is up to 10 megahertz. So now we will connect some pulse signal, and I will show you. So okay, whenever you are connecting with this probe, so down we will have the load 50 ohm or high Z. When you use the same oscilloscope probe to the function generator, better to go with high Z. Why? Because this probe is 10 mega ohm impedance. Okay. And coming to pulse, it is up to 100 millihertz to 10 megahertz. So now I am giving 5 megahertz. Okay. And even the voltage also you can give up to 10 volts peak to peak. Now it is 5 volts peak to peak. Or else even the same way we can give as a sine up to 10 megahertz. Okay, in this even it is possible to generate the modulations also. We can see a modulation, AM modulation, AM, FM, ASK, FSK, and functions are sine, rectangle, triangle, ramp. So these four modulations is possible with this oscilloscope. We have the sweep mode. You can give the start frequency, stop frequency. What is the sweep time you can measure? So it will be sweeping. Milliseconds. So 50 hertz, 50 kilohertz to 100 kilohertz I am giving. So I will change to 10 hertz. So it is just sweeping from 10 hertz to 100 kilohertz with 500 milliseconds. So sweep burst is also possible with this thing. With this, even you can use the BNC to BNC cable from this generator to the channels. That time you can go for 50 ohm load, and here it is mentioned that when you use 50 ohm, you should give less than or equal to 5 volts RMS, not beyond that. So this is the function generator. Even we do have the pattern generator. This is the pattern generator section. So this is a pattern generator. So these are the patterns we can generate. Like if a new engineer sit on the oscilloscope, he don't know how the I2C signal or a SPI signal. So initially you can generate from here. If you have selected I2C, or else I have selected SPI. So on the here you can see on the this thing, P3 has become a chipset, P2 has become a MSO, P1 has become a MOSI, P0 has become a clock, and normal this is the ground became a ground. So now you can at least you can with your digital channels you can connect 4, or if you're within your unlock channels also you can connect 4, and you can see the how the signal will be, and even you can decode that. You can in the when you select this SPI, you select what is the data rate, 100 kilobytes, 250 kilobytes, or 1 megabyte. Like this you can generate and you can see. So now I am connecting only clock. So now I have connected only clock. So this is my clock. So this is my clock of the SPI. So in the same way, even we can now this is the SPI. Now I will change it to I2C. So still P0 is the clock SCL. Okay. In clock CL I am keeping it 1000 kilobytes per. So this is my I2C clock bus. The same way even we can generate CAN, all these things, PWM, all the things you can generate. So before you can see how the signals will be. So if you see PWM, this is a PWM direction and enable. In the PWM you have the enable on off, direction left or right. So I am keeping direction as a right, enable on. My frequency is up to 500 kilohertz. So I am keeping as a 100 kilohertz. So you can see this is a PWM, pulse width modulation. So like this we can do many things before you go into the real time or on the boards. Here we have the pattern generator option. You can see all the options. Later on you can try it on your boards. So after pattern generator, Okay, so now here it's